Hi guys, so today we're going to cover 4.2 mass in the imperial system, or notes. So first off, difference between mass and weight. So the mass is a measure of the quantity of matter in an object. So basically what that means is if we're talking about you, it's how much stuff makes up you. Now your weight is how much the force of gravity exerts on you. So if I wanted to lose weight really quick, all I could do is hitch a ride on a spacecraft and go to the moon. So if I went to the moon and I weighed about 135 pounds, I would only weigh 22 pounds. So I just found a way to lose weight really, really quick, over 100 pounds of weight. Uh, but I'd still be made of the same amount of stuff. Okay, so I would still have the same mass if I went to the moon. So my weight had changed because there's not as much gravity there, but my mass would stay the same. Okay, it's not like I just lost parts of me. So even though they are two different things, when we're talking about mass in our systems, we're basically using these two terms interchangeably. Okay, so when I talk about mass, or when I say mass, what I am actually talking about is weight. But past this, you don't really have to remember that. So in our imperial system, remember this is not our metric system, so we're dealing with pounds and ounces. So most people in Canada still will know their weight better in pounds, not kilograms, which is the metric system. So this is not going to be too difficult to relate to. So 1 pound is 16 ounces. Oh, sorry, don't know why that's there. Get out of there, bracket. And a ton is going to be 2,000 pounds. So here we're talking about an imperial ton, 2,000 pounds. In our first example, we're just going to be doing a very simple conversion. So I'm turning 24 ounces into pounds. Now, if like the least amount of work you'd have to show for this is, okay, I have 24 ounces and I know I want to turn this into pounds and I know that 1 pound is 16 ounces. So all I'd really need to do is take 24 divided by 16 because there's 16 ounces in a pound, and I would get exactly 1.5 pounds. Now, if I was unsure that division was the operation that I needed to do, I could just set up a proportion. So let's do that. So I have 24 ounces and I want to turn that into pounds. So I want to know how many pounds that's going to be. So setting up my proportion, making sure our units are lined up. So ounces and ounces and pounds and pounds. I know that 1 pound here, so 1 pound is 16 ounces. So 16 ounces. And solving that proportion, so solving for this one, multiply and divide by the one that is across. So I would do 24 times 1, which is 24, divided by 16. So 24 divided by 16, which is exactly what I did here to get 1.5 pounds. Now, if I'd asked for pounds and ounces, your answer in pounds and ounces, like I do in the second example, you would actually say how many ounces are left over there. So I wouldn't have that decimal number. I would say, oh, well, I have 1 full pound, not 11 B's. Watch out with that, making sure you're leaving a good enough space. So 1 pound and half of a pound. Oh, well, if 16 ounces is a pound, then half of that is going to be 8 ounces. But I did not ask you to do that in this question, but we are going to have to do that here. So I have 54 ounces and I want to know that what that is, not in just pounds. So I can't have a decimal, just a decimal number, a nice easy one. I will have to have pounds and ounces. So 54 ounces, how many pounds and ounces will that be? Well, the simplest way to do that would be, okay, well, 1 pound I know is 16 ounces. So if I have 2 pounds, that is going to be 32 ounces. And 3 pounds is going to be 48 ounces. And I could keep going, but if I add another 16 onto 48, I'm going to go over 54 ounces. So I know I have 3 full pounds. And how much extra will I have now? Well, 3 full pounds gets me to 48 ounces, and I have 54 ounces in total. So I can do 54 minus 48, and I get, a difference of 6 ounces. So I have 3 pounds and 6 ounces. Now, if we had a large number, this would obviously not be a good way to do that. So how many full pounds will go into 54 ounces? So 54 ounces, and there are 16 pounds in an ounce. I get 3.375 pounds. Okay, so 3 full pounds is where that comes from. And now figuring out how much I have left over, well, 3 full pounds, there's 16 ounces in a pound, is going to give me 48. Oh, and I have full 54 ounces, subtract that 48, and I get 6 ounces left over. Okay, so it doesn't matter how you do it, it's just make sure you are showing me your work and how you got there. Okay, next example. Mike needs 1 pound, 2 ounces of mozzarella cheese, 12 ounces of cheddar, and 11 ounces of Swiss for a delicious fondue recipe. So how many pounds of cheese does she, because apparently Mike's real, need in all? So how many pounds? So 1 pound, 2 ounces, 12 ounces, and 11 ounces. Now there are a couple ways I can do this. Well, more than a couple, but I will just focus on 2. So one is what we did with our feet and inches and add pounds and ounces. So I have 1 pound, 2 ounces, and then there are 12 ounces, and then there are 11 ounces. So I could add those up and then turn those ounces into pounds. The other way, which is what we're going to do here, is, well, this 1 pound, 2 ounce would be pretty easy to turn into just ounces. So 1 pound, 2 ounce, well, 1 pound is 16 ounces. So if I have 16 ounces and another 2 ounces, I actually have 18 ounces here. And that other 12 ounces and 11 ounces altogether, I get 41. So 41 ounces altogether. Now, I want to know how many pounds. So all I have to do is turn that 41 ounces into pounds. So how many pounds will that be? And I'm going to set it up left and right this time instead of up and down like I've been doing. So if I was unsure whether I need to multiply or divide, I could always set up a proportion. So lining up our units, so ounces and ounces, pounds and pounds, and I know that 1 pound is 16 ounces. Solving our proportion, looking for this one, multiply across there and divide by the one that is opposite the x, the one I'm looking for. And when you do that, you get 2.5 0.5625 pounds. So I need 2.5625 pounds, or if you were just going to round that to the nearest 1 or 2 decimal places, take a peek over, I need about 2.6 pounds of cheese. Delicious, delicious cheese. Okay. Last example on this page, example number 4, we have one left. So the cab of Vince's semi-trailer weighs 8.7 tons and the trailer weighs 6.4 tons. The loaded gross weight of the truck is 21.4 tons. What's the weight of the load? What does that mean? Well, let's break this down a bit. So the cab of Vince's semi-trailer. So a cab of a semi is the thing you ride in. So here is the cab. Here is Vince. Oh, look, he's so happy. Hi. Okay. So here is my cab. So my trailer, let's just attach it there. Don't want a rogue trailer. Is this part. So here is my trailer. And inside of the trailer, I have what I am carrying, my load, or what Vince is carrying. Now, let's say he goes to a weigh station and they weigh what everything weighs together, and we know that that is 21.4 tons. We know the cab weighs 8.7 tons, and we know the trailer weighs 6.4 tons. So how much is the load? Well, I know altogether this truck weighs 21.4. So the cab plus the trailer plus the load is going to give me 21.4 tons. So in order to figure out what that load is, I just need to know the difference between what my cab and trailer are and what the total is. So taking a look, my cab and my trailer. So my cab is 8.7 tons. My trailer is 6.4 tons. Altogether, they are 15.1 tons, right? Now, I know that these two plus my load is going to give me 21.4 tons. These two altogether give me 15.1. So the difference is going to be what my load is. So in total, I have 21.4 tons in total. Subtract that 15.1 tons, and I get a difference of 6.3 tons. So that is how much my load will weigh. If I was unsure, I could check. So 8.7 plus 6.4 plus 6.3, I do get 21.4. Right. So part B of this question is, well, how much is that in pounds? So it's 6.3 tons. What is that going to be in pounds? So I have 6.3 tons, and I want to know what that is going to be in pounds. Okay, so lining up my units, tons and tons, pounds and pounds, I could check up at the top. Oh, 1 ton is 2,000 pounds in the imperial system. So 1 ton is 2,000 pounds. And solving my proportion. So looking for this one, multiply these two, divide from the one across from the thing I'm looking for. So I'm going to be doing 6.3 times 2,000. So 6.3 times 2,000, I get 12600 pounds. So 12,600 pounds is what 6.3 tons is going to be. So hauling quite a bit. Right. Example number 5, last one. So we have a 12-ounce can of vegetables that cost $1.49. Now those same vegetables in a 1 pound 2-ounce can cost $2.19, and we want to know which is the better buy. So remember, better buy just means which one is going to be the cheapest per, in this case, either ounce or pound. Okay, so we need to get these two numbers, or these two cans, to units that are the same. So they're both in dollars, but this one is in ounces, this one's in pounds and ounces. Now I could convert this one to pounds and then convert this one to pounds, or I can just convert them both to ounces since this one's in ounces already, which might be the easier way to do it. So let's do that. So remember, finding better buy, I do from my first unit, my price divided by my number of things. In this case, things is going to be how many ounces there is. It's an arrow. Okay, so let's call this can A and this can B. So can A, that 12-ounce can. So that 12-ounce can costs $1.49. So money is $1.49 divided by number of things. I have 12 ounces. So I do $1.49 divided by 12, and I get, it's in cents. Okay, so 0.124166, so on and so forth. All right, and I'm actually going to leave that like that, and you're going to see why in a second. Okay, so can B, I have a 1 pound 2-ounce can. Now I want to be able to compare this. So this is like 12.4-ish cents per ounce. So I want to know what this is going to be per ounce. So I need to figure out first, how many ounces do I have? So 1 pound is 16 ounces. So I have 16 ounces and another 2 ounces. So altogether here, I have 18 ounces in this can. And now I have it just in ounces. I can compare. Okay, so this costs $2.19. So money divided by number of things. So my number of ounces, my number of things is 18. So $2.19 divided by 18, and you get 0.12166, so on and so forth, dollars per ounce. Now taking a look at these two numbers, if we were just to round them to the nearest cent like we've usually been doing, so round this one around this one, it doesn't actually look like there is a difference in price. So this would be 12 cents, because I can't round up. And then this one would be 12 cents, because once again, can't round up. But taking a look at the unrounded number. Now 0.124166 and 0.12166. So this number is larger than this one. So my 1 pound 2 ounce can is the better buy. Now, if you're just buying one can, it's not going to matter whatsoever. You'd probably look more at, well, how many people am I feeding? Like, how much vegetables do I actually need? Do I need a 1 pound can of vegetables, or will a 12 ounce can be fine? However, if you were buying for a school or an event or something, and you needed these canned vegetables and you needed a lot of them, those fractions of a cent might actually be good to know. So figuring out which one you need. If you need a lot of those vegetables, you would want to go with the cheaper one to save that little bit of money there. Okay, and with that, you can go on to your worksheet. So 4.2 mass in imperial units. Okay.